Hey, what's up everybody? I'd like to welcome you to another Juice tutorial. And in this tutorial, we're actually going to build our first synthesizer plugin. So it's going to be very simple, but you'll actually be able to get notes to play out of a synthesizer plugin today. So this is going to be very exciting. Before we get started, let's remind you about your audio programmer community. So you can join the audio programmer community on Discord. It's a great way to connect with other people who are into audio programming and audio software development. We have audio developers of all different levels who are able to help each other out and talk about all things audio programming. You can join us on theaudioprogrammer.com/community and please join up. And also the code from both of these projects is going to be on our GitHub at github.com/theaudioprogrammer. So you can grab the code if you're missing it and you can actually join and follow along. So let's go ahead and get started. So here we have two projects that are open at the moment. We have our basic oscillator that we created in the first tutorial from the series. And then we have this project called TAP Synth, which is the kind of scaffolding the Juice synthesizer classes that we set up in our last tutorial. So what I'm going to do is I'm just going to open this up, this being the TAP Synth. So we'll open this up in our IDE. Actually, before we do that, I'm going to just shut that back down again. Sorry about that. We need to check a couple things. So going to our settings in our producer, what we want to do is we want to scroll down, and one thing we want to do is make sure in plugin characteristics we have checked in plugin is a synth and also plugin Midi input. Okay, so this is just letting the when it builds the VST, it lets it know that the plugin is a synth and it's expecting MIDI input, so it sets up the inputs correctly. So it'll do that. If you don't have both of these checked in, it will not work correctly, unfortunately. Another thing that we're going to do is we're going to make sure that our DSP module is added to our Juice modules. So just go to add a module, global Juice modules path, and Juice DSP. Okay, so now I'm just going to open that up in the IDE. And then here I'm going to open up the basic oscillator code up in the IDE as well. So we got two projects open at the same time. And now first thing we're going to do is we're actually just going to take all this stuff and we're going to copy it from the oscillator code and paste it into our Juice synth code. So we'll take all of this stuff where we declare the oscillator and the gain. We're going to put this in the synth voice class. So we'll just take that, put that there. Then we'll go to synthvoice.cpp. And here we have a prepare to play method. Okay, so we have this prepare to play method where we got all of this stuff where we're doing our setup. What we'll do is we'll copy this, and what I'm going to do is I'm actually going to create a prepare to play method in synth voice. Okay, so we don't have one at the moment. I will put this before render next block. So I'll just create a method. I will call this prepare to play, and then let's see what arguments it takes. Double sample rate and int samples per block. Double sample rate, int samples per block. And since this is not a method that is coming from synthesizer voice, we are not calling override. Okay, very important. And then in synth voice, once again, try to keep these methods in the same order. It makes it easier to read. So I can say void synth voice, since this is from the synth voice class, and then we've got prepare to play, and we have our sample rate and samples per block, and then I'm just going to paste all of that stuff that we had in our oscillator class. So we see that we're getting an error here because it doesn't have a identifier called get total num output channels. Okay, so there's no way that I see that synth voice can pass that information in. So I'm just going to add an additional argument here. I will say int output channels, and then I'm going to just call output channels here. And then I'm going to go back into where I'm prototyping these methods, and I'm going to call I'm going to add that argument as well. Okay, so I'm just going to build this, make sure this actually works very quickly. And in the meantime, I can actually close out the basic oscillator stuff. And so that built successfully, so that's fine. That's good to go. So far, so good. So now what we need to do is, one thing that I like to do whenever you have any of these prepare to play methods where you need to pass some information before we actually call it in our audio callback, I actually like to have a Boolean in here to make sure that I've actually declared this method, that I've actually used this method. So one thing that I'll do is I will create a Boolean here. I will just call bool is prepared. I'll set it to false. This is just a check to make sure that we aren't trying to use anything in our audio in our audio callback that before we've actually instantiated it. So is prepared, we will set to true once this prepare to play method is actually called. And then in here what we could do is we have this method called jassert. So this is a way that we can actually say if is prepared hasn't been called, then we want to stop execution of our project, and we want to say, hey, you forgot to call prepare to play. Okay, so I'll show you a demonstration of what that looks like a little bit later in the tutorial. So now we've pasted all of our, nearly all of our oscillator code. Sorry, I need to go back into the oscillator code again because we've forgotten one thing, which is very important, which is actually putting the oscillator audio information into our output buffer. So now we have all of this stuff that's in our process block, in our basic process, in our basic oscillator that we created. I'm just going to copy that, and now I can actually close this out. And we're just going to put this in render next block, where our actual audio code is being called. Now it's going to give us a complaint that it doesn't know what buffer is. That's just output buffer. So I can actually just copy that. I can paste it here. And now we should be good to go. And remember, render next block is actually just being called in our plugin processor method. So if we go down to the plugin processor, we have synth.render next block. Okay, so that is what is actually calling that on all of our voices. Okay, so now what we need to do, if you recall, just a really quick review, we have this class that we've created. So I'll try to explain this as plainly as possible. So we have our class that we've created called synth voice. So this is our own class. This is inheriting from synthesizer voice, which is a Juce class. Okay, so in our plugin processor, what we've done is we're adding this class that we've created, synth voice, to our synthesizer. Okay, and then what we need to do, remember, we need to call that prepare to play method, right? Where we have this prepare to play method, and we need to call that before we actually call render next block. So what we're doing is we will say for int I equals 0. And then we have this method where we can get our voices. So we have I is less than synth, get num voices, I++. And then what we will see here is we would think at first that we could just call synth get voice I, which gets each one of our voices, and let's have a look at our Juce documentation here so I can show you what I'm talking about. So in our synthesizer reference, we have this method called get voice, okay, which returns a synthesizer voice. Now this is where it may get tricky for you if you're just starting out. So remember, it returns synthesizer voice, which is a Juce class. Okay. Now, our class is called Synth Voice. It's not called Synthesizer Voice. So we actually need to get our class because we have this method called Prepare to Play. So we've created that, and that we won't have access to that method because this is returning a synthesizer voice. Okay, so if I try to call Prepare to Play, we see that there's no method called Prepare to Play. It says don't know what you're talking about. Okay, let me turn off my phone. Sorry about this. So what we need to do is we actually need to make sure we need to do a cast on the synthesizer voices and cast them as synth voices. And if it's successfully cast as a synth voice, then we can call the Prepare to Play method. So we can say if, and then we will do auto voice equals dynamic cast. And remember, we want to try to turn our synthesizer voice into a synth voice. And remember, this is returning a synthesizer voice pointer. And so we need to return a synth voice pointer. Okay. And in here, what are we trying to turn into a synth voice pointer? Each one of our synth voices, right? So we go synth, get voice, I, and now we can say if we've successfully casted our synthesizer voice pointer as a synth voice pointer, then we know it's a synth voice pointer, and we can call this Prepare to Play method. So I can say voice. Remember, this is a pointer, so we need the arrow operator, Prepare to Play, and now we see that Prepare to Play pops up. And then here we can just call our methods. So we got sample rate, samples per block. And remember, we have that method, that processor method called get total num output channels. So that is fine now. Okay, so now we are good to go. So I think that's fine for now. And now what we want to do is we want to have a way that we can actually control the when we actually turn the sound on and off, right? So normally in a synthesizer, that would be an ADSR, attack, decay, sustain, and release. And that would control when it would know when we're actually pressing the key to actually turn the sound on and when we're releasing the key to turn the sound off. So Juce has a handy ADSR class. Here we are. So we have this ADSR class, and we have kind of its child class called parameters, ADSR parameters, where we can actually declare an attack, decay, sustain, and release that we can actually use to control when the sound actually turns on and off. So here we have note on and note off methods. We have a reset method as well. So let's go ahead and start using some of this stuff. So first thing that we'll do is we will create an ADSR object. So I will just put this above our oscillator. Doesn't really matter. So we got Juce, ADSR, and I'll just call this ADSR. And then we have to create some ADSR params, ADSR parameters. I'll call this ADSR params. I'll just build this while I'm going to the synthvoice.cpp. Just make sure that we're actually building okay. Yep, so we're fine. So in here now we can call, so let's see here. So once again, whenever you're using these things, it's good to make sure that if there is some sort of method that you need to call to set the sample rate. So we see that there's a method here called set sample rate, and we will need to use that. So we could say ADSR. So I'm going to just put this above this. So ADSR set sample rate, and then here we pass the sample rate. Okay, and then that's it for that. And then going back to our documentation, we have two ways that we can actually call this method. We can use this getNextSample, which does sample by sample processing. I'm going to use this one called apply envelope to buffer, where I can actually pass in the audio buffer, the start sample, and number of samples that I want this to apply to, and we can do this conveniently like this. So in here, in render next block, one thing that I'm going to do actually is I'm going to make sure that prepare to play is actually called and that all the sample rates are set before I actually try to do any audio processing. So one way I could do this is I could do a Boolean. A lot of times Juce actually has their own checks here, but I like to just do a double check. So I'm going to call a Boolean is prepared. I will set this to false. And then in the prepare to play method, once all of this is called, I could call is prepared equals to true. And then in render next block, what I want to do is I want to make sure that all of this, that all of our objects have their sample rate information before I try to do anything. So what I could do is I could do what's called a JAssert, and then I could say is prepared to make sure that that's true. So if I just say is prepared, then that will be fine. You could also do is prepared is equal to true. That's saying the same thing. So both of those things are the same. I just like to say is prepared. So that's fine. And now we have all of this stuff. And now we have our oscillator and our gain. And all we need to do is we just need to apply our ADSR to it. So I can actually just say ADSR after all of this, after the oscillator has done its thing in the audio block, and I can say ADSR apply envelope to buffer, and in here I just put my audio buffer. So we got output buffer, start sample, and num samples. Okay. Now, if you're looking at this carefully, you may say, how can you do that? Because the ADSR is, you may say the ADSR isn't going to apply to the audio block because aren't you putting the oscillator data into this audio block? Okay. So when you're trying to apply the ADSR to the buffer, that's not going to actually apply to the code that you put in the audio block. Well, if you recall, going back to our first tutorial in this series, I was telling you that an audio block is actually just an alias. It's actually talking about the same thing as the output buffer. Okay, so if I'm putting audio data into the audio block, I'm actually putting it into the output buffer. Okay, so what that means is that when we get to this line of code 65, output buffer will contain all of the audio data that we've put in it through osc.process. Okay, so I hope that makes sense. Okay, so audio block is the output buffer, basically is what I'm saying. Okay, so it's just another handy name for it. So I hope that doesn't confuse you. And once again, going back to plugin processor.cpp, then we have our process block, where in here later we will do our audio processor value tree state and put our attack, decay, sustain, and release. And then we call this synth.renderNextBlock, which calls synth voice render next block on each one of the voices. So now we should be able to go ahead and actually test this out, and we should have a synthesizer that we can actually play. Actually, I forgot something else. We need to actually apply our envelope to when we're actually playing notes. So going back to our ADSR, we have these methods called note on and note off. Okay, so what we will do is we will actually look at where we could put those. Okay, so a natural place for note on to me would be where we have ADSR start note. Okay, so I could just say ADSR note on. And then in stop note, we can just say ADSR note off. Okay. Another thing, if you're watching carefully, is you might say, oh, but our oscillator is always going to play at 220 hertz. Okay. So that's always going to play at the same frequency, same note. So that's not very handy, is it? So we could actually just take this. We're going to cut this out of our prepare to play method, and we can actually use our MIDI note number. So we can actually take in the MIDI note number that the user is playing, and we can actually use that to change the frequency of our note. So what we will do is I will paste set frequency in here, and we actually have this handy Juce method from the Juce MIDI message class, and I think it's called get MIDI note in hertz. Here we go. And in here I can just pass the MIDI note number, and it will change it to the corresponding frequency in hertz. So that's how we're going to set our frequency for our oscillator. So now I think we're ready. If you're in Xcode, so what I'm going to do is I'm going to open this up in our DAW. So I use Ableton. So to do this in Xcode, as I always say, you can go, so I'm building for VST3, you can go down to Edit Scheme, then in Executable, you would choose Other, and then you would go to your Applications folder and choose the application you want to open this up in, and I choose Ableton. Okay, so that's how you would do that there. Visual Studio is a little bit more complicated. I should, one of these days, I should do a tutorial on how to actually do that in Visual Studio. So I will do one of those at some point. So now we're opening up Ableton, and I hope all of this works the first time around. So in here, I built for VST3, so it'll be in my VST3 folder. Just go down to your company, and we will just put this on a MIDI channel. And we see that we have this synth, and it actually doesn't have any UI or anything. But if I press a key, oh, it's very soft. I'm not sure if you can actually hear that, but it's actually playing. You can see in the volume, using the volume meter there. Okay, so yeah, you can see that it's actually playing. 1 second, I'll actually just turn it up just a little bit, just in case. There's this utility. Just turn output gain. Okay, so I hope you can hear that, but yes, the sine wave is actually playing. And that's it. So you built your first synthesizer. Congratulations. Okay, so we don't have a UI yet. We can set up the UI very soon, and that will be the subject of our next tutorial. So we also haven't actually given the ADSR as parameters: attack, decay, sustain, and release. So we can't actually modify the sound just yet. So this is just a basic synthesizer, like the hello world of synthesizers in Juce. So that is where we're going to end the tutorial for now. The next tutorial, what we'll do is we will actually start setting up our audio processor value tree state, and with the attack, decay, sustain, and release parameters, and actually be able to control our sound a little bit and change oscillators. So I hope you enjoyed this tutorial. Please give it a like and subscribe if you haven't subscribed, and I will see you next time.